An A380 with an engine mount called foundry avant. A breakfast served with wine jelly. Or a BMX bike equipped with hardcore wheel rims. These products all have two things in common. They're industrially produced and made in Germany. But the production of bicycle wheels, jellies, or airplane parts requires raw materials and energy sources that are scarce in Germany. There's no engine mount without titanium in a cast. No wine jelly without gas under the pot. And no wheel rims without water in an adonizing cell. German industry imports 190 billion euros worth of raw materials and fossil fuels each year. That makes the efficient use of resources especially important in Germany. Tital is a mid-sized company located in the town of Bestwig in western Germany. Here, more than 400 workers manufacture parts for the motor racing, aviation, and aerospace industries. The main ingredients are aluminum and titanium, two raw materials that require a lot of energy to produce and are expensive to buy on the world market. Until recently, the A380's engine mount had to be milled out of a giant block of titanium. 90% of it was waste. In an effort to save resources and money, the company developed a brand new production process, casting the mounts instead of milling them.
Titanium fine casting reduces costs by 30%. That's a reduction of 7.5 tons of CO2 compared to the milling process.
The process requires less material and less energy than conventional techniques. The company has developed a fine casting oven that saves costs and protects the environment as well. A 250-kilogram titanium electrode is fastened to the inside of the oven. Engineers truly appreciate the material because it's light and flexible, but also solid and anti-corrosive. After the titanium electrode is placed in its position at the top of the oven, technicians mount a ceramic mold in a large steel container. The steel container with the mold is moved into the oven below the titanium electrode. Finally, the smelting chamber is sealed airtight for the casting process. A copper crucible is positioned in the middle of the oven, and an extremely powerful current is applied between the crucible and the electrode. This creates temperatures of more than 4,000 degrees Celsius. The titanium melts. And the molten metal is poured into the cast. The entire process takes about 1 hour. The ceramic cast now contains the molded mount of an A380 engine. But first, the mount must be freed from the ceramic mold. The new casting process was supported by the German Environment Ministry's Environmental Innovation Program. Compared to the earlier milling process, The Tital company only needs 1/4 of the energy and 1/4 of the expensive titanium previously used to make the same part. After the pipes through which the liquid metal flowed into the cast are cut free, the mount is finished. The efficient use of resources pays off, and not just for the production of the A380 engine mount. The same thing is happening back on the ground.
Noch 2 Grad, dann Horas, dann ist fertig.
Workers at a preserves factory in Germany's Rhineland region have also discovered an efficient use of resources. The company produces a wine jelly made from a traditional family recipe. The wine is heated in a 50-liter pot. Larger batches lose their flavor and don't taste the way customers have come to expect. A pot of this dimension requires a lot of gas to cook over an open flame.
The wines are pumped up from the cellar into these tanks. That's the portion we process here in one day. The whole thing is warmed up with a flow heater so we can start the production right away.
The family-owned Pfaffmann company processes wine from various wine growers across Germany. Up to 70,000 liters are stored in the cellar. Heating that much wine in conventional pots throughout the year would require a lot of energy. That's why the wine is pumped through a tube and warmed up in a heat exchanger before it reaches the pots where it's processed into jelly. It's an efficient method that also lowers the company's gas bill by 1/3. After it's been cooked, the hot wine jelly is poured into jars. For hygienic reasons, the jelly has to be cooled quickly, and that's a problem. The company used to place the jars in a bath of cold water, producing 200,000 liters of wastewater each year. But in cooperation with environmental engineers, Pfaffmann developed a new cooling process that works according to a surprisingly simple principle. The jars are now sprayed, and the coolness of evaporation brings them down to the desired temperature.
We've invested around 10,000 euros in the 2 units. We reckon it will pay for itself in 2 years, and will keep saving energy in the future.
Saving energy and raw materials is also an issue in a totally different industry. Air acrobats aren't the only ones who use aluminum. The lightweight metal plays an important role in outdoor sports, car manufacturing, and medical technology. A company in the German town of Wetzlar provides just the right color to bicycle wheel rims made of aluminum by the process of galvanic adonizing. The aluminum rim is soaked in several solutions. The decisive reaction comes in the Adonization solution. Here, sulfuric acid ions play an important role. An electric charge is applied to the rim, attracting ions which give off oxygen. That makes the surface porous, allowing the pigment to bind with the smooth aluminum. The voltage also causes particles to collect on the other side, hydrogen protons on the so-called backing electrode. As a result, tiny aluminum particles free themselves from the electrode and combine themselves with the sulfuric acid. The problem is there aren't enough free sulfuric acid ions, and the process is interrupted. Either the current flow must be increased or the adonization solution turns into toxic waste. In order to save resources and money, the Wetzlar company uses a special retardation process. Inside the unit, part of the adonization solution flows through a special resin, which draws back the sulfuric acid ions and allows the aluminum particles to move again. Water flushes the sulfuric acid back into the adonization solution, and the chemical process can continue. The new technique is paying off for the company.
The retardation process allows us to save around 18,000 to 20,000 euros in chemical costs and cut down on cooling and energy costs as well. The unit will have paid for itself in about 2 years.
The benefit is not only financial. The adonization process is followed by the actual pigmenting of the aluminum. Constant purification maintains the right concentration of sulfuric acid ions in the adonization solution, and the aluminum parts in the solution also possess a consistently porous surface. That way, the color particles bind with the aluminum. This results in a high-quality and deeply glazed layer of color. The implementation of resource-saving procedures not only cuts costs, it also improves the production quality. Technicians gain a better overview of material flows that improve their ability to steer the entire procedure. Along with the acid from the adonization solution, the unit in Wetzlar also purifies and recirculates the water it uses for the process. The waste heat resulting from the purification is also used in a further process. This allows Wetzlar engineers to conserve 90% of the wastewater and a quarter of the energy. These environmental protection measures can be transferred to other industries as well.
The principle of resource efficiency is easily transferable, and one advantage is that companies gain access to corresponding public funds at the federal and state level.
Whether it's the production of wine jelly, engine mounts, or bike wheels, using resources efficiently can save German industry more than 150 billion euros a year.